So I've been saying that if we multiply both sides by an expression involving the variable, we have to watch out for extra solutions. And by an expression involving the variable, I mean any sort of polynomial in the variable where we're working. So we could multiply by x times x minus 1, anything of this nature. If we multiply by any of these things, what we want to do is we want to go to the end of the problem, try and plug in whatever answers we've gotten, and make sure that they are all real. But something else happens if you multiply not by a polynomial in the variable, but by a rational expression in the variable, or you could say if you divide by something with the variable. So a rational expression includes things like this, 1 over x, right here. So what happens if we multiply both sides by a rational expression, or we could think of it as dividing, in this case, by a polynomial that involves the variable? Well, let's look at this. This equation, x cubed equals x. Okay? How might we solve this? Well, one thing you could say is, hey, let's just multiply both sides by 1 over x. Okay, let's say we do that. Now we have x squared equals 1. Well, we can solve this. It's a difference of squares. So I know that either x equals negative 1 or x equals 1. I go back to the original equation and I ask myself, do these both fit? Absolutely. 1 cubed equals 1 and negative 1 cubed equals negative 1. Because a negative times a negative times a negative gives us a negative. So we might think that we've successfully solved this equation. But the problem is something happens when you divide by an expression with the variable, or you multiply by a rational expression that ends up having the variable in the denominator. And what happens here? Well, you can lose an answer. And that might be even more dangerous than getting an answer that obviously doesn't fit. What do I mean by lose an answer? Let's do this same problem one more time. But let's use a different method. So this is our problem. We want to find all solutions. Let's just factor. There's something in common here. This is a difference of squares. And what do I get? I get a product equal to 0. So when any of these three pieces is 0, this equation will be satisfied. So I know x equals 0, or x equals minus 1, or x equals 1. Okay, so how many solutions? 3. Do they all work? Absolutely, we checked these two before, but now we have x equals 0, which also works, because 0 is equal to 0. So look at what happened last time. Okay, we had x cubed equals x, same problem, and we only got 2 of the expressions. So what happened here? Well, 0 is one of the solutions to the original equation. And what we did when we multiplied by 1 over x in that case, for the solution x equals 0, that's like multiplying both sides by 1 over 0. So we have to be careful whenever we divide by something that contains the variable. How did we do it correctly this second time? Well, we didn't divide at all. What we did is we just factored. And it's always safer not to divide by something with a variable in it. Because if you divide, say, by x minus 1, and 1 is a solution, well, you've just erased that solution, or possibly erased that solution. If you divide by x minus 5, and 5 is a solution, you've just erased that solution. So, if I have something like this, and I can choose, hey, do I divide both sides by x squared, or do I try to factor first? I would always choose to try to factor first, because dividing by an expression with a variable or multiplying by a rational expression that has the variable in the denominator is dangerous business. What can we conclude? What have we seen? Okay, multiplying by a rational expression that only has the variable in the numerator might create fake solutions. Multiplying by one that has the variable in the denominator might erase real solutions. Both of those are dangerous because you want to find all the solutions. So we have to be careful. Let's do a few more examples and see when this comes up.